the following four main functions. Add notes. This feature allows users to add new notes for a specific topic. Users need to enter the subject, note content and timestamp. The client passes this information to the server, which saves the new note to an XML database. The key code to implement this function is the add_note function in client.py and the add_note function in server.py. Get notes. This feature allows users to retrieve all notes under a specific topic. The user enters a topic of interest, and the client sends the request to the server. The server looks up all the notes under the topic in the XML database and returns them to the client for display. The key codes to implement this function are the get_notes function in client.py and the get_notes function in server.py. Query Wikipedia. This feature allows users to search Wikipedia for information on a specific topic. The user enters a search term, and the client sends the request to the server. The server uses the Wikipedia API to query and obtain the title and link of the relevant page, and then adds the result as a new note to the XML database. The key code to implement this function is the query_Wikipedia function in client.py and the query_Wikipedia function in server.py. Client interface. This is a command line interface that allows users to interact with applications. Users can choose any of the above three functions or choose to exit the application. Based on the user selection, the client will call the corresponding function to handle the request. The key code to implement this function is the client_interface function in client.py. The server.py code is the server-side implementation, while the client.py code is the client-side implementation. They communicate via remote procedure calls, RPC. The following is the specific implementation process. Server-side, server.py. The server creates an XML_RPC server instance using the XML_RPC.server.simpleXML_RPC server class and listens on the specified port. The server has registered three functions add_note, get_notes, and query_Wikipedia, to provide remote services. The add_note function is used to add a note to an XML database. It uses the xml.atree.elementtree module to manipulate XML files. The get_notes function retrieves all notes for a specified topic from an XML database. The query_Wikipedia function uses the Wikipedia API to query for information on a given topic and adds the results as a note to the database. The server uses the server.serve_forever method to keep running, waiting for client requests. Client, client.py. The client uses the XML_RPC.client.serverProxy class to create a proxy object for connecting to the server. The client loops through a list of server URLs to achieve load balancing across multiple servers. The client provides a command line interface where users can choose to add notes, get notes, or query information on Wikipedia. The client calls the corresponding server function to perform the operation requested by the user. The client uses the handle_exception decorator to catch and handle exceptions that may occur. In summary, the server provides three remotely callable functions using the XML_RPC protocol. The client implements remote procedure call, RPC, communication by creating proxy objects to call these remote functions. The two use data in XML format to communicate, and the client can connect to multiple servers to achieve load balancing. The client implements exception handling through a decorator function called handle_exception. This decorator function will be applied to all remote function calls that may throw exceptions. This decorator function defines an inner wrapper function that wraps the original function call. In the wrapper function, a try-except statement block is used to catch various possible exceptions. First, it tries to execute the original function. If an XML_RPC server failure exception XML_RPC.client fault occurs during execution, it will print out the corresponding error message. Secondly, If a protocol error exception xmlrpc.client.protocol error occurs, the corresponding error message will also be printed. Finally, for any other uncaught exceptions, it prints a generic error message. By using this handle_exception decorator, the client can handle various possible exceptions gracefully and provide meaningful feedback information to the user without crashing the entire application. This greatly improves application robustness and user experience. All client functions involving remote function calls, such as add_note, get_notes, and query_Wikipedia, use the @handle_exception decorator, thus ensuring consistent application of the exception handling mechanism. Heterogeneity: heterogeneous components must be able to interoperate. In this XMLRPC-based client-server application, the client and server can run on different hardware and operating system platforms and can communicate with each other as long as they follow the XMLRPC protocol. This design makes the system highly heterogeneous and can support component integration in different environments. Openness: the interface should allow components to be added or replaced. The application uses the XMLRPC protocol to define a remote call interface, so that new server-side functions can be easily added and existing server-side components can be easily replaced. This loosely coupled design improves the openness and scalability of the system. Security: the system can only be used as intended. Although the current version of the code does not cover security aspects, by implementing authentication and authorization mechanisms on the server side, you can ensure that the system can only be used in the expected way, thus improving the security of the entire system. Scalability: the system should be able to handle an increasing number of clients. The client of the application implements a simple load balancing mechanism that distributes requests to multiple servers through a round-robin list of server URLs. This design helps improve the scalability of the system and can cope with the increasing number of clients. Fault handling: the failure of one component should not cause the failure of the entire system. As we discussed before, the client implements the exception handling mechanism through the handle_exception decorator. Even if a server fails, the client can still switch to other servers, thus avoiding a complete failure of the entire system. This design enhances the fault tolerance and availability of the system. Transparency: hide the distributed nature from clients. For the client, it only needs to interact with the XMLRPC server and does not need to care about the specific implementation details and distributed characteristics of the server. This transparency makes the client code more concise and reduces the complexity of the distributed system.